where the initial step begins. Empty firecrackers are arranged in cakes, bottom closed, and after inserting fuse, these cakes are fed into the conveyor belt in the Zone 2. Zone 3, ash filling area. The next step in the process of the machine is ash filling. The ash filling area has a motor of capacity 380 volts and 1.1 kilowatts. The ash is mixed well and filled into each firecracker tube. Mixing takes place, and the cakes are filled uniformly with the powder from the funnel. The leftovers from the powder filling area are recycled by a set of conveyor belt and make lesser wastage. Similarly, the leftovers from the ash filling area are recycled by another set of electromechanical processes, such as control of machinery on factory assembly lines and other fixtures. This PLC controller is combined with a monitor with which the whole process can be monitored step by step. This type of PLC control unit and its monitor is fixed near the feeding area. Zone 2, feeding area. This is the area where the initial step begins. Empty firecrackers are arranged in cakes, bottom closed, and after inserting fuse, these cakes are fed into the conveyor belt in the Zone 2. Zone 3, ash filling area. The next step in the process of the machine is ash filling. The ash filling area has a motor of capacity 380 volts and 1.1 kilowatts. The ash is mixed well and filled into each firecracker tube in the cakes fed in the conveyor belt. Zone 4, individual chemical feeding bin. In order to fill the chemical powder effectively and safely, 2 out of 4 chemicals, potassium nitrate and barium nitrate, are mixed separately in a bin, and the other 2 chemicals, sulfur and aluminium powder, are mixed individually in feeding bins. These feeding bins are driven by a motor of capacity 380 volts and 0.75 kilowatts. These 2 chemicals and the other 2 chemicals are fed on the conveyor belt individually without mixing. The conveyor belt carefully takes these 2 rows of chemicals into the next zone. Zone 5, powder filling area. The belt takes the chemicals to powder filling area. These chemicals fall into a funnel where uniform mixing takes place, and the cakes are filled uniformly with the powder from the funnel. The leftovers from the powder filling area are recycled by a set of conveyor belt and make lesser wastage. Similarly, the leftovers from the ash filling area are recycled by another set of conveyor belt and make lesser wastage. These 2 conveyor belt sets are driven by a motor of capacity 380 volts and 0.75 kilowatts. Between the powder filling area and the white magic mud filling area is the vibrator. This vibrator makes effective chemical blending and settling of the chemical powder. This vibrator is operated by a motor of capacity 380 volts and 0.75 kilowatts. Zone 6, white magic mud filling area. After passing through the vibration line, the cakes move to the Zone 6, where the white magic mud is filled, and then the vibration line makes effective settling of the white magic mud, which is operated by a motor of capacity 380 volts and 1.1 kilowatts. Zone 7, collecting area. Finally, the powder-filled, finished firecracker cakes are collected in the collecting area. The collected cakes can be taken for finishing or knitting purposes after an hour of drying. Altogether, daily production capacity for this machine is 1000 cakes per hour. That makes 8000 cakes. The chemical flowing areas either make use of rubber belts or aluminium vessels. Our processes pass through safe rubber conveyor belt of thickness 4 mm. The powder filling area is completely surrounded by safety firewall of 50 centimeters. Risk factors are very low, with the whole machine being operated by just 3 laborers. 2 bins for individual chemical mixing before entering into powder filling area. All spilt ash and spilt chemical powder gets recycled and the feedback is completely used. To prevent the friction, 3 mm rubber sheet is put on the floor. Lightning protecting system. Economic viability, a comparative analysis. The total production using this machine per day is 8000 cakes per day. So, these calculations are made basic of 8000 cakes. Manual type of work. Labor cost for 8000 cakes. Tissue paper soaking, washing and scratching. One worker makes tissue paper for 1000 cakes. Rupees 800. Tissue paper pasting and piercing. One worker can work with 125 cakes. Rupees 8000. Ash filtering and sieving. One worker makes 2000 cakes. Rupees 400. Chemical powder sieving and filling. One worker can fill 500 cakes. Rupees 3600. Top mud filling. One worker fills 1000 cakes. Rupees 1600. Top mud piercing and inserting fuse. One worker can work with 30 cakes per day. Rupees 39,900. Separating individual tubes by breaking cakes. One worker can break 500 cakes. Rupees 2,400. Total 600 to 700 cakes can be done per day. Rupees 56,700. For making 8,000 cakes manually, it hardly takes 12 days of manual labor for a labor cost of Rupees 56,700. Now, let's see the cost for the fully automatic powder filling machine production. This machine makes use of 3 motors of capacity 380 volts and 0.75 kilowatts. 2 motors of capacity 380 volts and 1.1 kilowatts. This machine can be operated by 3 workers. For risk-free handling, let's consider 4 workers operating this machine. Working with the fully automatic machine. Cost. 3 motors equals 2,250 watts. That makes use of 2.25 units of electricity per hour. Rupees 68. 1.1 kilowatts of 2 motors equals 2,200 watts. That makes use of 2.2 units of electricity per hour. Rupees 66. for 4 workers and 1 supervisor. Rupees 800. Total Rupees 934. For making 8,000 cakes with the machine, it costs Rupees 934 only, and the finished cake can be taken for work the same day after an hour.